Hi everyone. Yeah, so we'll be going through my statistical machine learning assignments where I work on a prostate cancer data set to classify a person as someone who has prostate cancer or not. So it's a classification task. So the first thing to do is to look into the data set and see what the sample size and the observation and the dimensionality is. And we discover that we are dealing with an ultra high dimension because our dimension is more than the sample size. So basically, we use Kruskal-Wallis test to check to get the top nine variables, top nine predictors that can help us separate our response variable into the zero class and the one class, and we got that using Kruskal-Wallis test. So so I plotted the box plot of these top nine predictors and see whether Kruskal-Wallis test is really true. And this is evident because the box plot of these variables really show that they can separate our response variable into two different class correctly. So using the old data sets, I built a tree of with CP equal to 0.01. Remember, the dimension of our input space is 500, and coming out of this tree, we only have three variables. That means that only three variables are really important to tell us about our response variable. They can help us to classify our response variable into the zero class or one class. So this is really something unexpected. That means that this tree has done a lot of pruning. Out of 500 variables, only three comes out. And we could see that the root of this variable is part of the variables Kruskal-Wallis gave us as the top predictors that can help us classify our response variable. So this is the box plot for the weakest variables, and we can see from the box plot that these variables cannot help separate, did not give us information to separate our response variable from to either zero class or one class. So here is the co-plots, and we see that co-plots for the top nine variables, some of these variables are highly correlated. This means that we can use one of the variables that are highly correlated. That's one of them is redundant, so we don't need them in our model, and some are not correlated at all. That means that we can use them in our model. So we try to learn six different machines on this data set, three KNNs and three classification trees. And from the ROC curve we got, we discovered that one NN is doing best, and this is expected because we train our data set with the old data, we train our model with the old data, and we test it with the old data as well. So we expect the one NN being the complex of the KNNs to return to have an error to an error of 0%, and the true positive rate should be 100%, which is expected. And looking at the classification tree with CP equal to 0, which is also the complex of all trees, we expect this one to also give us an error of 0%, but in this case we do not have that. So this is unexpected. And the trees with CP equal to 0.05 and 0.1 are basically doing the same thing. They classify our response variable the same way, and we have 1n, 7n, and 9n. This is a plot of different using different CP. The CP we have in our model, we have CP equal to 0, CP equal to 0.5, and CP equal to 0.1. And we see that 0.05 and 0.1 are clearly at the same thing. They are the same thing. So here is a box plot of our model, the error of our model, and from this box plot, we can't statistically, there's no significant, we can't see the one that is the best or the worst because the box plots are just the middle line of each of them are just on the same line. So we can't see statistically which one is the best. So here we perform an ANOVA test, and an ANOVA with the p-value very small, we discover that there is a statistically significant difference between our six models. That means that at least one of these model is performing better. And we try to use 2K to get the pairwise comparison of these models. And yeah, it's evident that some of these model are one of the model is doing better. And when the KNNs are compared with the trees, discover that the KNNs are doing better than the classification trees. Yeah, so this is all about my answer. Overall, I see that Kruskal-Wallis test help us to see the variable that helps separate our response variable. Thank you.